October 2025. NASA scientists tracking an object hurtling through our solar system at over 130,000 miles per hour noticed something that made them stop. The interstellar visitor wasn't behaving like it should. Jets erupted from its surface in patterns no one expected. Its brightness surged without warning. And when Harvard astronomer Avi Loeb ran the numbers on its trajectory and behavior, he calculated the odds of this being a natural object at roughly 1 in 100 million. Now, as it moves through space on a path that brings it within 168 million miles of Earth this December, the question isn't just what this thing is. The question is whether we're watching something that traveled billions of years across the galaxy by accident or by design. Discovery, a faint speck from beyond. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System telescope in Chile picked up a faint speck of light moving against the background stars. The observatory had been scanning the southern sky as part of NASA's Planetary Defense Program, designed to catch anything that might threaten Earth. This object registered at magnitude 18, barely visible even through powerful telescopes. Within hours, astronomers at the Minor Planet Center in Cambridge, Massachusetts got the alert and started calculating its path. What they found changed everything. The object was moving on a hyperbolic orbit with an eccentricity of 6.1374. In simpler terms, it wasn't bound to our sun. It came from somewhere else entirely. By July 2nd, confirmation arrived from observatories worldwide. The Zwicky Transient Facility at Palomar Observatory in California, the Nordic Optical Telescope in Spain, and facilities across 3 continents all tracked the same impossible trajectory. The International Astronomical Union designated it 31, making it the only 3rd confirmed interstellar object ever detected passing through our solar system. They named it Atlas after the survey that found it, but when astronomers dug through archived images, they found something unsettling. The object had been photographed as far back as May 7, 2025, at a distance of 6.4 astronomical units from the Sun. At that range, most comets sit dormant and frozen. This one was already active, already glowing, already doing things it shouldn't be doing that far out in the cold. The James Webb Space Telescope turns its instrument towards 31 Atlas on August 6, 2025. Dr. Sarah Chen's team at the Goddard Space Flight Center in Maryland processed the spectroscopic data through the near-infrared spectrograph. The results showed carbon dioxide pouring off the object at 129 kilograms per second. Water vapor followed at 6.6 kilograms per second, along with carbon monoxide, carbonyl sulfide, and traces of nickel and cyanide. Standard comet composition, nothing strange here, but the ratios were off. This thing carried way more carbon dioxide than water, the opposite of what we see in comets born in our solar system. The Very Large Telescope in Chile detected organic compounds in the coma, complex carbon molecules that form when ultraviolet radiation hits methane ice over millions of years. That kind of chemistry takes deep time and deep space. Behind that fuzzy cloud of gas and dust at the nucleus, the actual solid body of the comet. Hubble images from July 21st showed a teardrop-shaped coma stretching 26,400 kilometers across, but the nucleus itself stayed hidden inside the haze. Too small and too far away to resolve directly. Size estimates ranged anywhere from 320 meters to 5.6 kilometers in diameter. That uncertainty matters because of what came next. Ground-based telescopes watching the comet's light curve measured how its brightness changed as it rotated. The period came out to 16.16 hours, one complete spin every 2/3 of a day. The rotation was steady, clockwork precise, showing no wobble or tumble. For an object that had been drifting through interstellar space for potentially billions of years, getting hit by cosmic radiation and micrometeoroids the whole time, that kind of stability seems almost engineered. Then, the brightness changed. Between late September and early October, as 31 Atlas fell toward its closest approach to the Sun, it suddenly brightened beyond every prediction. Models based on its size and distance said it should hit magnitude 11.5 at best. Instead, it surged to magnitude 9.8, more than 6 times brighter than expected. Dr. Michael Rodriguez at the Jet Propulsion Laboratory in Pasadena ran the calculations 3 times thinking he'd made an error. He hadn't. The comet was outputting more light than any natural model could explain. Standard comet behavior involves brightening as you get closer to the sun because heat turns ice into gas. But this surge happened too fast and too strong. Something inside was generating energy that the sunlight alone couldn't account for. October 3, 2025 brought another anomaly. The European Space Agency's ExoMars Trace Gas Orbiter was studying the Martian atmosphere when mission controllers noticed 31 Atlas passing just 0.1935 astronomical units from the red planet, about 18 million miles. They diverted the orbiter's cameras to capture images. The photos showed the comet's coma looking slightly elongated, stretched in the direction of its motion. But they also showed something else. Multiple thin streamers extending from different points on the nucleus, each one aimed in a slightly different direction. Not the broad fan-shaped jets that spinning comets produce. These were narrow, focused, almost like exhaust from multiple small thrusters firing independently. Post-perihelion observations in November revealed that jet activity had intensified. Ground telescopes counted at least 7 distinct jets extending millions of kilometers into space. The comet was shedding mass at roughly 5 billion tons per month. The jets didn't line up with simple sunlight-driven outgassing. Natural comet jets form on the side facing the sun where ice gets heated. These jets fired from multiple points, including areas that should have been in shadow, cold, and inactive. Polarimetry studies showed that dust particles in those jets had unusual optical properties, suggesting they contained crystalline silicates and complex organics. Material that formed under very specific temperature and pressure conditions that might not exist anywhere in the outer reaches of a planetary system. Dr. Avi Loeb at Harvard's astronomy department published an analysis on November 8th looking at the statistical probability that 31 Atlas formed naturally. He factored in its size, which sits in a range rarely seen for interstellar objects. He factored in its trajectory, which entered our solar system nearly perpendicular to the plane that most objects follow. He factored in the jet activity and the unexplained brightness surge. When he ran those numbers through models of how objects get ejected from star systems and drift through the galaxy, he arrived at odds of roughly 1 in 100 million that all these characteristics would appear together by chance alone. Loeb stopped short of claiming the object was artificial, but he did note that those odds would improve dramatically if he allowed for the possibility of technology, of something deliberately built and sent on a journey through the stars. The skeptics pushed back. The scientific community responded with strong skepticism. Dr. Brian Cox at the University of Manchester called the speculation completely unfounded. Dr. Amanda Martinez at the Space Telescope Science Institute pointed out that weird doesn't equal alien. Comets from other star systems might behave differently than our stars simply because they formed under different conditions, around different types of stars, in regions with different chemical makeups. Just because we've never seen this exact combination of traits before doesn't mean it violates natural law. The data shows a comet. An unusual one, sure, but still a comet doing comet things. The radio detection, water, but wrong timing. Then on October 24th, the Meerkat Radio Telescope Array in South Africa detected something that settled one debate while opening another. The array picked up absorption lines at 1665 and 1667 megahertz, the signature frequencies of hydroxyl radicals. Those radicals form when sunlight breaks apart water molecules. The signal confirmed that 31 Atlas was definitely shedding water, thousands of kilograms per second of it. That's standard comet behavior, case closed on whether it's a comet or some kind of solid asteroid. But the timing of the detection raised questions. The hydroxyl signal appeared strongest when the jets were most active, but it didn't always line up perfectly with which side of the nucleus faced the sun. Sometimes the water release peaked when the theoretical hotspot should have been rotating away from solar heating. Either the comet had hot spots on its night side, or something else was driving the water release. A trajectory from the ancient galaxy. The trajectory deserves closer attention too. When 31 Atlas entered our solar system, it was moving at 61 kilometers per second relative to the sun. That's hyperbolic velocity, escape speed, the kind of speed that means you're not coming back. Its path brought it in from the direction of Sagittarius, from the thick disk of the Milky Way where old red dwarf stars cluster. Kinematic models suggest it could be anywhere from 3 to 14 billion years old, potentially older than Earth, older than our Sun. It crossed Neptune's orbit sometime in mid-2023, spent 2.5 years falling toward the inner solar system, reached perihelion at 1.356 astronomical units on October 29th, and now it's climbing back out. It'll pass Earth on December 19th at 1.8 astronomical units, about 168 million miles away. No danger whatsoever. Then it continues out past Jupiter in March 2026, and eventually leaves the solar system entirely by 2028. The statistical problem with the path. But here's the thing about that trajectory. Natural interstellar objects should enter our solar system from random directions, distributed evenly across the sky because they've been wandering the galaxy for millions or billions of years. The galaxy's rotation and stellar motion should scramble their paths into basically a random distribution. 31 Atlas came in at 175 degrees inclination, meaning retrograde, moving opposite the direction most solar system objects orbit. That's not impossible for a natural object, but its path lies unusually close to the ecliptic plane, the flat disk where planets orbit, only 4.89 degrees off. Statistical studies of how debris gets ejected from planetary systems suggest most interstellar wanderers should arrive at higher inclinations, more randomly tilted. The fact that 31 Atlas came in so close to our planetary plane sits in the tail end of the probability distribution. Not impossible, just unlikely. Add to that everything else, and the pile of unlikely things start to get harder to ignore. December 19th, our last best chance. December 19th, 2025 marks the closest approach to Earth. Every major observatory will be watching. The Hubble Space Telescope has time allocated. The James Webb Space Telescope will take additional spectra. Ground-based facilities across 6 continents are coordinating observations to track the comet every hour of that day. The European Space Agency's Jupiter Icy Moons Explorer spacecraft, currently en route to Jupiter, will photograph 31 Atlas from a different angle than Earth-based telescopes can achieve. Those images won't arrive until February 2026, when the spacecraft relays the data, but they'll show the comet from a perspective we've never had before. And there's talk, just preliminary discussion, about whether any spacecraft currently in the outer solar system could adjust course to get a closer look. The Juno probe at Jupiter is the only candidate, but even that would require burning fuel Juno needs for its main mission studying Jupiter's magnetosphere. No decisions have been made. The window is closing. What we do know is that 31 Atlas is leaving. After December, it gets fainter and fainter as it climbs back out into deep space. By mid-2026, it'll be too dim for most telescopes. By 2028, it crosses beyond Neptune's orbit and disappears into the dark between stars. This is our window. 3 months to gather every piece of data we can, to answer every question while the object is still close enough to study in detail. The chemistry of its coma tells us about the molecular cloud it formed in billions of years ago. The structure of its jets tells us about how its nucleus is built and how it's coming apart. The way it moves tells us about the forces acting on it, whether those forces are purely natural or something else. We might never see this object again. We might never see another object like it. A new era of interstellar visitors. The broader context matters here. 31 Atlas is only the 3rd confirmed interstellar visitor we've ever detected. The first, Oumuamua in 2017, caused controversy because it showed unexplained acceleration and had a weird elongated shape. The second, Borisov in 2019, looked and acted like a normal comet, which was almost disappointing after all the speculation about Oumuamua. Now we have 31 Atlas, which brings back some of that mystery. The Vera Rubin Observatory, set to begin operations soon, should detect interstellar objects every year or two once it's fully operational. We're entering an era where these visitors won't be once-in-a-generation discoveries anymore. They'll become regular occurrences, chances to study material from hundreds or thousands of different star systems. Each one carries information about planetary formation conditions light years away. Each one is a sample return mission we didn't have to launch. The longest look we've ever had. But 31 Atlas stands apart because of how early we caught it. May 2025 recovery images mean we've tracked this object for 7 months before closest approach, and we'll track it for months after. That's the longest observation baseline we've had for any interstellar object. More data means better models. Better models mean we can start to separate what's genuinely anomalous from what's just our lack of experience with this class of objects. Maybe the brightness surge will turn out to have a perfectly natural explanation once we understand the mix of ices better. Maybe the jet patterns will make sense when we map the nucleus rotation and surface composition in more detail. Or maybe we'll find something that really doesn't fit. What proof would look like? Speculation about something alive or something artificial probably won't be resolved by observations alone. If this were a probe, if something built it and sent it here, we'd need to see clear evidence of technology. Structured radio transmissions at frequencies that don't occur naturally. Surface features too geometric to be erosion and impacts. Trajectory changes that can't be explained by outgassing. We haven't seen any of that. The radio signals we detected are hydroxyl radicals from water, completely natural. The jets, while unusual, don't violate physics. The trajectory, while statistically unlikely, is still within the range of possible for a natural object that got ejected from its home system billions of years ago. Everything we've observed can be explained without invoking intelligence or design. This requires explanations we haven't needed before because we've never studied an object quite like this one. 22 days until closest approach. So, here's where we stand. An object from beyond our solar system, older than our world, moving through space at speeds no human spacecraft has ever reached, is about to pass within a cosmic stone's throw of Earth in less than 3 weeks. It's showing behavior we can't fully explain with standard comet physics. It's made of materials that suggest it came from a very different kind of planetary system than ours, and one of the leading astronomers studying it has calculated odds that suggest natural formation alone might not account for everything we're seeing. In 22 days, we'll have our best and last chance to learn what this thing really is, where it came from, and what its presence here means for our understanding of what exists out there in the galaxy. Every telescope that can see it will be pointed at the sky that night. Every detector will be recording, and whatever answers we find will either put the speculation to rest or make the mystery even deeper.